All right, so starting this week, we're going to look at different line and angle relationships. So you're going to have notes today, Friday, and Monday, and then your quiz will be on the notes that we take on those 3 days. Today, we're going to look first if we have two lines that are coplanar. Remember, coplanar means in the same plane. All right, these lines, they can intersect and be, first word is oblique. All right, these are lines that intersect, but not at a right angle. So you would just have one like that. All right, so they're going to meet, they're going to intersect, just not at a right angle. The ones that do intersect at a right angle, those are called perpendicular. So these are lines that intersect at a right angle. So remember, when we draw lines and we want to show that they are perpendicular, all right, we have to draw the box in the corner. That's what represents perpendicular. You may also see perpendicular lines in this three-dimensional box here. All right, now not all the pictures, or sorry, not all the angles look like they're 90 degrees, but you'll see boxes in the corners. All right. You might even see one like up here, even though that doesn't look 90. You'll see a box drawn like that. You can say, and these would be segments, so we could say segment DH with the bar over it is perpendicular to segment HG. That's how you would write that. Right? And then don't forget the upside down T means perpendicular. Parallel. These are lines, again, in the same plane that never intersect. Now, first over here, let's draw them just separate. So if we had two parallel lines, all right, and on the paper they don't intersect, but we wanted to make sure that we knew that they were parallel, we would put a double arrow at one end or the other. It doesn't matter which one. So that's what you'll see on the picture. Again, when we have the box, we can have parallel lines. All right, so this segment here, DH, and this segment over here, CG, would be parallel. Right? They will never intersect. How do we write that? Well, again, we put the bar because we're talking about a segment. All right, and then we use two slanted lines like that to show parallel. Okay. So those are three, again, that will be coplanar, in the same plane, oblique, perpendicular, parallel. If lines are not in the same plane, all right, then they can be what we call skew. So they have to be in different planes. They are not going to be parallel, and they are not going to intersect. So when we're talking about skew lines, you will see this three-dimensional box. So what you're looking for to help you is pick one side that runs, let's say, horizontal, and then you need to pick another line on the back plane that would run vertical, like this. Could be AE, or we could have picked BF. There is no symbol for skew, so we would simply say segment HG is skew to segment AE. All right, but the lines have to be on completely different planes. So notice HG was on what I would call the front plane. So then I went to the back plane to find one that ran vertical. Because if you pick ones that actually run in the same direction, okay, then those can be parallel to each other. Here, if we can have two planes that never intersect, then those planes will be parallel. So we can have lines that are parallel, we can also have planes that are parallel. All right, so just to kind of shade them in, I'm going to pick the top plane and then the bottom plane. All right, and of course in this three-dimensional figure, the top and bottom are parallel, the front and back are parallel, and your two sides are parallel, so you can pick any. Now, to name a plane, remember, we use just 3 letters. So for this top plane, I would just pick the letters A, B, and C. Again, we can use that parallel symbol. And then down here again, any 3 letters, I'll just use E, F, G. All right. The next thing we need to talk about are different angle relationships that occur when we have what's called a transversal. A transversal is simply a line that's going to intersect 2 or more coplanar lines, but at different points. So here's 2 lines. All right, intentionally I drew them so that they do not look parallel because they do not have to be. But if I draw a 3rd line that cuts through both of them, like that, this one that I drew is called a transversal. It's cutting through the other 2 lines. Now, when we have that situation, when we have 2 lines cut by a transversal, there are 4 special angle relationships that are formed. All right, the first one are called corresponding angles. Now, I'm going to give a description of these, not so much a formal definition, but a description. So with corresponding angles, what you're looking for is they need to be on the same side of the transversal, meaning the angles do, same side as the transversal, and in the same position. And what I mean by that is they both need to be above or both below the other 2 lines. All right, so when we look at this picture, all right, here's my 2 lines, and then this line running more vertical, not exactly, but running up and down would be the transversal. So the angles that are on the same side would be 1, 3, 5, 7. And then we also have 2, 4, 6, 8 are also on the same side. Now, to be in the same position, we want them both above or below the other 2 lines. So if I look at angle 1, it is on the left side of my transversal and above. So I need down here the angle that is going to be to the left and above the other line. All right, so left, they're both left and above. So we would just say angle 1 and 5. That's 1 pair of corresponding angles, but there's lots. So 3 and 7, they're both left and below. So 3 and 7 are corresponding. On the other side, I've got 2 and 6. They're to the right and above. And then 4 and 8 are to the right and below. Okay, so those would be corresponding angles. The next relationship are called alternate interior angles, and the name tells you exactly what's going on. If they're alternate, these are on different sides of the transversal. And if they are interior, then they are inside the other 2 lines. Why can't I put the R on the word other today? Okay, so when I look at my picture, all right, different sides and inside. So notice, all right, 3, 4, 5, and 6 are my interior angles. They are inside these 2 lines. So if I want them to be inside, but also on different sides, then that would be, so angle 3, and then down here in this cluster would be angle 6. They are on different sides, but both inside. So angle 3 and 6 is 1 pair. And the other alternate interior angles would be 4 and 5. Okay, so there's only 2 pairs for alternate interior. The next angle relationship are called consecutive interior. Now, you may also here then be called same side interiors. Right? I'll be using consecutive interior, but same side interiors sometimes shows up on some worksheets. All right, so of course, consecutive interiors will be on the same side of the transversal. And the word interior again tells us they will be inside the other two lines. All right, so again, 3, 4, 5, and 6 are my interiors. So if they need to be on the same side, then this time we're looking at 3 and 5. And then on the other side would be 4 and 6. Now, I'm intentionally going to label these different, and you'll have better understanding of that tomorrow. Okay. And then the last angle relationship are called alternate exterior. So again, the word alternate tells us these are on different sides of the transversal. And exterior tells us they will be outside the other two lines. All right, so looking at our picture, the exterior angles, we've got 1 and 2, and then down here 7 and 8. So those are my exteriors, but if I need them to be alternate, I'm going to pick 1, and then down here on the other side would be 8. So that's one of the angle pairs. And then the other would be 2 and 7. Okay, so your job today, besides the vocabulary on the first page, is to be able to identify these different angle relationships. So let's take a look and do some examples there. All right, quick review. All right, we've done vertical angles and linear pairs. Now notice when we have a transversal, we create what I call 2 clusters of 4 angles. So when we're talking about vertical angles, we're in the same cluster. All right, so this angle here and this angle here, those are vertical. These are in the same cluster. Same thing happens with a linear pair, right? We're looking for 2 angles that are adjacent, that form a straight line. So that would be this one and this one. All right, again, I intentionally did them different because most of the time, those are not the same measure. Vertical angles are always congruent, linear pairs are not. All right, but these are in the same cluster. In order to have our new 4 relationships, right, corresponding, alternate interior, alternate exterior, and consecutive interiors, you're going to have 1 angle in each of the 2 clusters. So let's take a look. All right, using the diagram below, it says identify each pair of angles as corresponding alternate interior, alternate exterior, consecutive interior, but maybe linear pair of vertical angles. All right, so the very first one is angles 7 and 3. So 7 and 3, they're in different clusters. So think of our 4 new ones. They're on alternate sides, different sides, and they are both interior. So these would be alternate interior angles. All right, 2 and 3. 2 and 3, again, different clusters. They're on the same side and they're both interior. So these would be called consecutive interiors. Number 3, 7 and 1, these are in the same cluster and they're opposite. So these are simply vertical. Okay, vertical angles. 8 and 4. 8 and 4, notice different clusters. They're on different sides of my transversal and they're both on the outside. All right, so these would be alternate exterior. All right, 8 and 6, again, different clusters. They're on the same side and they're in the same position because the 8's exterior, the 6 is interior, but they're both above these two lines. So these are corresponding. Same side, same position. Okay, 2 and 4. All right, again, different clusters. So think about our new relationships. They also are on the same side. They're on the left side and they're both below. So again, these are also corresponding. 7 and 8. All right, notice they're in the same cluster. They're not opposite, but they're right next to each other. So that forms a linear pair. 2 and 6, different clusters. They're on different sides, so they're alternate, and they're both inside. So these are alternate interiors. All right, 6 and 4, same cluster. These are opposites. So those are vertical. 6 and 7. All right, they're on the same side and they're both interior. So we call our same side interiors consecutive interiors. All right, 1 and 8, they're in the same cluster, right next to each other. That's a linear pair. And 1 and 3 are our last pair. Ooh, let me pull it up. 1 and 3 are on the same side and they're both above. All right, same side, same position. Those are corresponding. And then it asks us to name the transversal. The one cutting through the other two lines is line K. Now, I do want to point out that some angles don't have any of these relationships. All right, if I look at my picture, all right, actually, I'm going to add in here, no relationship. All right, for instance, for example, angle 1 and angle 6, all right, those are both, they're alternate, they're on different sides, but one is exterior and one is interior. There's no special name for that. So angle 1 and 6, you would simply say that those have no relationship. All right, so 3 and 8 would be the same, even though they're alternate, one's exterior, one's interior. So 3 and 8, we would simply say no relationship. All right, 2 and 5 would be another that have no relationship, and 7 and 4 have no relationship. So please don't force a relationship. There might not be one, all right, or at least one that has a special name for it. All right, you should be ready to practice. So find your Thursday work.